Section 12.1. This is on parametric equations. Now, the word doesn't make sense, but I like to think about it as para, meaning pair of equations, even though P-A-R-A is not pair. And so what happens is you get an x and a y that are defined in terms of t. T usually is respect to time. So you have two things, an x and a y, that are changing with respect to the time. Now, in this particular problem, they want us to go from 0 to 8. And they want us to graph and analyze it. All right, so easiest way to do this is to make yourself a little chart like you did back in, Algebra 1? Except now you're going to have a t, an x, and a y. And your t goes from 0 to 8. And now we're going to plug the numbers in. When you stick 0 into the x, I'm going to do all the x's first. I get 0, 2, 4, 6, 8, 10, 12, 14, and 16. On the y's, if I stick in 0, I get negative 4. 1 gives me negative 7 halves. 2 would give me 4. 2 minus 4, negative 2. 3 is going to give me 9 over 2 minus 4, 1 half. 4 is going to give me 16, 8, 4. 5 is going to give me 17 halves. 6 is going to give me 36, 18 minus 4, 14. 41 halves, and 28. Now, the easiest thing to do is to just graph these. The thing is, you have to graph them in order, and you have to keep track of their order. So the first point, we're graphing x versus y, and the t is actually going to be on the graph. So x is 0, y is negative 4. And if I count by negative 5s here, I could put a dot right there. And that's when t is 0. So I'm going to label this t equals 0. The next dot happens when t is 1, it's at 2. And the book is counting by 2, so I'll count by 2s. Oh, yeah, because it's, okay. 2, comma, negative 7 halves. Negative 7 halves is a little higher than that, so right here. Then I have, at t is 2, I have 4, 2. So that's going to be about here. And then I have 6. 6 gives you 1 half. Whoops, what did I do? No, 4 gives you negative 2. That dot's in the wrong place. It's about right here. Not that one. 6 gives you a half, so here's 6, and so it's right close to the line. 8 gives you 4, so it's right here, because this over here would be 5. 10 gave you 17 halves. 17 halves is a little higher than 8, so right about here. 12 gave you, oops, what did I do? T is 4. Okay, so now I'm graphing. That was 8, 4. When t is 5, and these fractions, I want to skip them. When t is 6, it was 12, 14. So let's just go to 12, 14. 14's way up here. And we keep on going. When t is 8 was another next whole number 1. It was 16 and 28. Oh my goodness. 10, 12, 14, 16, 18, 20. No, 5, 10, 15, 20. This is 25. This would be 30 up here. And so I need this one to be 2, 6, 8, 10, 12, 14, all the way to 28. So about here. Oh goodness, it gets really steep all of a sudden apparently. I think my dashes might be off a little bit. So when I draw this one in, I need to put on arrows so I know which direction it went in. That's the whole point about this. This was t equals 8, this was t equals 12, and so on. And I'm not going to put them all in there because it gets really cluttered. Now, sometimes, not always, you can get rid of the t. It's called eliminating the parameter. To eliminate the parameter, I would take that x equation and solve it for t. And then I would come over to my y equation and put in what t is. And that would end up giving me 1/8 x squared minus 4, which is a parabola. So the part that we graphed is part of a parabola. It looks like the right-hand side from 0 to t equals 8. So example 2 wants us to look at x equals 4 the cosine of 2 pi t, y equals 4 the sine of 2 pi t, for t between 0 and 1. Okay, so the trick on this is to pick ones that we know. So this is x and this is y. And from 0 to 1, I'm going to start at 0, and I think I'm going to go by eighths. The next one will be a quarter. The next one will be 3/8, then a half. And I may not need this many dots, and I'm probably going to skip the ones that come out ugly when I graph it. After 1/8, yeah, I'm not even going to go. The next thing will be 5/8. I'm not going to do that. 3/4 and 1. And you'll see why here in a second. So when I stick in t is 0, I'm doing the cosine of 0, which is 1 times 4 is 4. When t is 1/8, I'm doing 2 pi times 1/8, pi over 4. Cosine of pi over 4 is square root of 2 over 2. Times 4 would be 2 the square root of 2. That's not one I'm going to plot. 1/4, that would be 2 pi times a quarter is pi over 2. Cosine of pi over 2 is 0. Times 4 is 0. I'm not going to do this guy. We'll just skip that one. 1/2, that would be 2 pi times a half is pi. Cosine of pi is -1 times 4 is -4. And 3 pi over 4 times by the 2 pi would give me 3 pi over 2. Cosine of 3 pi over 2 is 0, so this is 0. And then 1. Cosine of 2 pi is 1 times 4 is 4. Let's go to the y's. Same deal. Stick in 0. Sine of 0 is 0 times 4 is 0. I'm going to skip that one. Putting in a quarter, I'm doing pi over 2. That's 1 times 4 is 4. Putting in a half, I'm doing pi. Sine of pi is 0. And 3/4 would be 3 pi over 2, which is -1 times 4 is -4, and then 2 pi is back to 0. Oh goodness, that's supposed to be a straight line. Okay, so I'm graphing my x and my y's. I'm going to count by ones. Okay, so 4, 0 is right here. 0, 4 is right here. -4, 0. 0, -4, and then we're back around to the same dot I started on. And this is a circle. It's not going to be a nice smooth circle because I can't draw a perfect circle. Kind of looks elliptical, but it's not. Apparently my tick marks are bigger on the x than they are on the y. But it is a circle, and the orientation went this way, around the circle. It started here. This was t equals 0. This was t equals 1/4. This was t equals 1/2. This was t equals 3/4. And this was back at t equals 1. So we made a circle. Now, I can look at that circle, and you should be able to too. That is a circle centered at 0, 0 with a radius of 4. So its equation should be x squared plus y squared is 16. So now what if I didn't recognize it? Okay. So let's look at what x squared plus y squared would be. And it would be 4 the cosine of 2 pi t squared plus 4 the sine of 2 pi t squared, which turns into 16 cosine squared of 2 pi t plus 16 sine squared of 2 pi t. Factor out the 16, and we have this, which I call the granddaddy. It's the Pythagorean identity, and this piece right here is equal to 1, so x squared plus y squared would be 16. So we see that this parametric equation is equivalent to the circle of radius 4 centered at the origin. Now there's a generalization for this, and it says anytime you have x squared plus y squared being equal to some number cosine of bt squared plus the same number sine of bt squared, this same thing is going to happen. You're going to end up with a squared out here and a cosine squared of bt plus a sine squared of bt, and so this will always turn into 1, and you'll end up with your x squared plus y squared equals a squared. Okay, that concludes example 2.